Powers of 10 and scientific notation. Our objective is to evaluate and multiply by powers of 10, as well as convert between standard notation and scientific notation. Why learn this? Powers of 10 can be used to read and write very large and very small numbers, such as the masses of atomic particles. Let's look at powers of 10. So we're going to start with the positive integer exponent. If n is a positive integer, find the value of 10 to the n by starting with 1 and moving the decimal point n places to the right. So if we have 10 to the 4th, for example, we're going to start at 1 and then we're going to move the decimal 4 places to the right. You may recall, oh, it's 10 to the 4th. That means we have to have 4 zeros. Well, this is what's happening to make that the case. What about negative integer exponents? If n is a negative integer, find the value of 10 to the negative n by once again starting with 1 and moving the decimal point n places to the left. So say we have 10 to the negative 6th. We talked about in the previous section that that's really like 1 over 10 to the 6th. Well, we start at 1, and then since it's negative, we're going to move 6 places to the left. So 1, 2, 3, 4, 5, 6, which is going to leave you with 5 zeros because you're starting on the right-hand side of 1. Let's practice. So we're going to find the value of each power of 10. So we're going to start with 1, and in this case, we're going to move the decimal 3 places to the left. So 1, 2, 3. Fill in our little holes here. So it's really 0.001. Take a moment and pause the video and try B and C. When you return to the video, the answer will be revealed below. So for B, we start at 1, and then we're going to go 2 places to the right, leaving us with 100. For C, we're going to start with 1, and then we're going to move 0 places. So, well, if we start at 1 and we don't go anywhere, we're left at 1. But hey, this looks familiar. Anything to the 0 power is 1. Rule still applies. Now let's try going the other way. So we're going to write each number as a power of 10. So the decimal point is 7 places to the right of 1. So you have 10 to the 7th. Now let's look at B. The decimal point is 3 places to the left of 1, so the exponent has to be negative 3. So 10 to the negative 3. Let's look at C. It just says 10. The decimal point is 1 place to the right of 1. 1 place to the right of 1. So therefore the exponent has to be 1. Well, 10 to the 1 is 10, just like 5 to the 1 is 5. You can also move the decimal point to find the product of any number and a power of 10. You start with the number instead of starting with 1. Alright, so if the exponent is a positive integer, move the decimal point to the right. If the exponent is a negative integer, move the decimal point to the left. So we have 125 times 10 to the 5th. Well, since it's a positive 5, we're going to move the decimal 5 places to the right. So 1, 2, 3, 4, 5, you'll have 5 zeros. Well, if you have 36.2 times 10 to the negative 3, start where the decimal point was, and just simply move 3 places to the left. Let's practice. So we have 97.9 0.86 times 10 to the 6th. That means we want to move the decimal point 6 places to the right, leaving us with 9, 7, 8, 6, 0, 0, 0, 0. One, 2, 3, 4, 5, 6, and it was between there. Alright, so now let's try B. Take a moment and pause the video and try it on your own. Now that you've had a moment to try it on your own, let's look at it together. So we have 19.5 times 10 to the negative 4, which means we need to move the decimal point 4 places to the left. So we start where the decimal point was, and we're simply going to move it 4 places to the left. So we have 0.00195. So scientific notation is a method of writing numbers that are very large or very small. A number written in scientific notation has 2 parts that are multiplied. So kind of like what we were doing before in the previous 2 examples, only there's one more specific piece that has to happen. The first part is a number that is greater than or equal to 1 and less than 10. This is very important. For it to be in scientific notation, the number can't be like 35.7. It has to be between 1 and 10. So it has to be greater than or equal to 1 and less than 10. The second part is a power of 10. This is similar to what you were doing in the last 2 examples. Let's practice using an astronomy application. Jupiter has a diameter of about 143,000 kilometers. Its shortest distance from Earth is about 5.91 times 10 to the 8th kilometer. And its average distance from the Sun is about 778,400,000 kilometers. Jupiter's orbital speed is approximately 1.3 times 10 to the 4th meters per second. So now let's look at a couple of examples. We want to write Jupiter's shortest distance from Earth in standard form. So its shortest distance from Earth is about 5.91 times 10 to the 8th kilometer. So we have 5.91 times 10 to the 8th kilometer. But we want to write it in standard form. So when writing it in standard form, that means we need to move the decimal point 8 places to the right. So now we have 591,000,000. So 591 million kilometers. The kilometers doesn't change. We just went from scientific notation to standard form. So in the next one it says, write Jupiter's average distance from the Sun in scientific notation. Try this one on your own. When you come back to the video, the answer will be revealed below. And there you have it. Now let's try comparing and ordering numbers in scientific notation. We're going to order the list of numbers from least to greatest. Step 1. List the numbers in order by powers of 10. So let's look at our powers of 10. We have our smallest power of 10, 10 to the negative 4. So that's going to go first. So we're going to write our entire piece here with 10 to the negative 4. Then we have 2 of them with 10 to the negative 1. So we're going to write both of those down. And then we have, the next one we have 4, and we've got 2 with 5. So we put the 4 and then the 2 with 5 down. Step 2. Order the numbers that have the same power of 10. So there's no other one with a power of -4, so that one's going to stay right where it's at. And now we want to look at, once again, we're going least to greatest. So we want the smallest one between these two here. And that would be the 1. So we have 1 times 10 to the -1 next. And then following would be 1.2 times 10 to the -1. There's only 1 with a power of 4, so that one stays as such. But we have 2 with powers of 5. So take our smallest, which is going to be 2.4, and that goes first. After you've done a couple of these, you may not have to write out the entire step 1 before you get to step 2. You might be able to do them all in your head in terms of, okay, well, you found the smallest power of 10, so you've got 10 to the -4. There was no other one, so you knew that had to go first. Then you look and you go, okay, I've got 2 with 10 to the -1. Which one was smaller? Okay, this one's smaller, so I write this one first. But if you have to, you can write it all out just like it is here. And that will also end our video on powers of 10 and scientific notation.